Have you ever been frustrated trying to locate or define a specific setting on your VNA, such as frequency, power, averaging, ports, or IF bandwidth? Have you ever had a hard time defining VNA calibration kit coefficients? Do you wish it could be easier to move from initial setup to calibration to validation to measurement? And if you own more than one VNA make and model, have you lost time trying to configure identical calibration settings and perform identical tests on different units, only to land up with measurement inconsistencies because some setting didn't match up?
Hi, my name is Chase Gibson. I'm a technical sales specialist with Mori Microwave, and today we're going to take a look at how we can empower all VNAs with an intuitive and easy to use software interface, which makes going from the initial setup to calibration to validation to measurement on any VNA a breeze. In front of me, I have a typical S parameter measurement system comprising of a VNA, calibration kit, calibration verification kit, and sample device under test. This is likely similar to what you have in your lab. The only difference is that my system is being driven by Mori Microwave's Insight software platform. Insight is the industry's first commercial VNA calibration, validation, and S parameter measurement software designed to empower all VNAs with an intuitive and easy to use software interface, resulting in accurate and repeatable data that will help give you confidence in your measurements. Well, let's get things going.
Today's demonstration will concentrate on Insight's intuitive and easy to use software interface. Keep in mind, this is the only interface you will ever have for any VNA in your lab, whether it's a 20-plus-year-old HP 8510 or a state-of-the-art PNAX. When you start Insight, you have three options. The first option, Configure, allows you to define your equipment. You will only need to go through this menu when initially defining your instruments, VNA calibration kits, or characterizing the uncertainty of your system components. The second option is Calibrate, Validate, Measure. This is where you will spend most of your time, and our wizard will guide you through the three steps in an intuitive and pain-free manner. The third option is Plot. This tool is extremely useful to plot and analyze your S parameter measurements, and offers capabilities well beyond any commercial VNA. Let's start with Configure. Going into Configure, we are presented with several buttons. The first defines our VNA instruments and is what allows us to have the same interface for any VNA. Here, you can configure your HP, Agilent, Keysight, Wiltron, Anritsu, Rohde Schwarz, or copper mounted VNAs, then set the GPIB, USB, or LAN address and ensure proper communication. You can also choose to characterize the drift and noise floor of the VNA so that the VNA's uncertainties can be added to the overall measurement uncertainty. The second tab allows us to define our entire collection of calibration kits. It doesn't matter if the kits come from Mori or one of the VNA vendors. This is where you will define it once, and Insight will make it compatible with all VNA makes and models. As a side note, if you're using a Mori CD calibration kit, this is where you would load the individually characterized data files. The CalKit uncertainty would then also be added to the overall measurement uncertainty. Lastly, you can characterize the uncertainty contribution of the cables, connectors, or on-wafer probes using your measurement setup so that those uncertainty contributions can also be applied in your final DUT measurements. Once we are done defining our VNAs, CalKits, and optionally characterizing our system components uncertainty, we move on to the Calibrate, Validate, Measure wizard. Calibration starts with the Profile Setup. Profile Setup allows us to create a new calibration project which consists of all of our calibration settings, or we can load a pre-saved setup or even recall a calibration. This is incredibly useful in ensuring identical calibration settings are used each time and across multiple benches, resulting in a more consistent and repeatable calibration process. You can also choose whether to include measurement uncertainties and define whether the measurement setup will be connectorized or on wafer. For this demonstration, we are going to set up a new profile. In this case, we will include uncertainty as it is a critical part of our improved VNA calibration validation process. We will also select a connectorized setup. First, we'll select a VNA from our database, define the ports, port power, averaging, and IF bandwidth. Next, we will define the start and stop frequencies, the step size, and the number of points. Following that, we will define our calibration method, connector type and gender, and specific calibration kit being used from our database. And lastly, we can define our cable and connector uncertainties so that they are included in our calibration and DUT measurements. For more information about characterizing uncertainty, please watch our Insight Uncertainty demonstration on YouTube. Saving the setup creates that project file that can be reloaded later on or shared among colleagues to make sure everyone is calibrating the same way. Insight now prompts us to perform the calibration defined earlier. In this case, it is asking us to measure an open, a short, and a load. For the sake of time, let's fast forward to the end of the calibration. Once the calibration is complete, Insight prompts us to validate. In the validation menu, we can choose either the legacy source match technique using an airline and short circuit termination, or the more definitive verification kit technique. We will proceed with the verification kit technique. After validating the calibration, Insight prompts us to move on to measure. The measurement interface brings us together all of the measurement settings and options needed to take accurate and repeatable measurement. As shown on the screen, you have the choice of manually adding plots with plenty of different parameters to choose from, and if you're not too sure what parameters to plot, you also have the choice of loading in predefined quick plots. Sweep mode can be changed from single to continuous or hold. In addition, VNA settings such as eye of bandwidth, averaging, and port powers can be adjusted here. If the uncertainty was characterized in previous steps, it can be activated at this point, and the individual uncertainty contributions analyzed. With the uncertainty, your measurement isn't a line, but a region. Also, measurements can be de-embedded, appended, and normalized on the fly. In the plotting interface, one or more plots can be custom configured or added from predefined quick plots. And in addition, you can analyze and post-process one or more files at the same time and share with colleagues.
Insight will help eliminate frustrations trying to locate or define a specific setting on your VNA and make it easier to move from VNA to VNA without the hassle of having to relearn the new interface each time. Also, Insight's intuitive and easy to use software interface ensures an accurate and repeatable measurement regardless of whether you are using a 20-plus-year-old VNA or this year's model. As an additional benefit, using shareable standardized calibration project profiles will help ensure you are calibrating your VNA the same way every time across all VNAs and ensure consistent measurements. For more information on Insight, please visit moreemw.com. Thanks for tuning in.